Hello everybody, this little video on how to calculate an inverse. This is a short video about theory to see why we will use the extended Euclid algorithm to compute an inverse. So the hypothesis is that we are working in Z over NZ, and let's choose some A bar element such that the GCD of A and N is equal to 1, that is, A and N are relatively prime or coprime numbers. So this hypothesis that A and N are coprime actually tells us that actually A bar has an inverse in Z over NZ. So if you don't remember that, please look at the previous video about the ring structure of Z over NZ. So in order to calculate the inverse, we'll use a tool we've seen before, which is Bezout's identity, that tells us the general formulation is whatever for all A and B there exists a couple U V such that A times U plus B times V is equal to the GCD of A and B. So this identity we will apply to a couple of values, which is A, so the A related to the A bar elements we've chosen, and to the value of N. So for A and N, we know that according to Bezout's identity, sorry for this wild zoom during the video, so there exists a couple U V such that A times U plus N times V is equal to the GCD of A and N, and actually, as an hypothesis, this GCD is equal to 1. So, with GCD of A and N equal to 1. So let's write it to be sure that this hypothesis is used for writing Bezout's identity. So now, how to make the link with the fact that we are looking for the inverse of A bar in Z over in Z. So actually, if two quantities are equal, here A times U plus N times V is equal to 1, so those quantities are also equal modulo N. So that's not a trick, that's true. So what you have is that there exists a couple U B such that A modulo N times U modulo N plus N modulo N times V modulo N is equal to 1 modulo N. So if we have a look on this equality, we have actually two things that are very, let's say, very cool for us, is this and this. N modulo N is always equal to 0. And 1 modulo N is always equal to 1. So actually, the second part of the quantity on the left will disappear due to the fact that N modulo N is equal to 0, and we end up with A modulo n times u, sorry, that's not the good color, u modulo n is equal to 1. Then, as actually modulo or reminder, we can translate it in z over nz with this kind of writing, that is a bar times u bar is equal to 1 bar. And here we find the relation between those two numbers is that actually u bar is the inverse of a bar. So that's how one calculates the inverse of an element in Z over NZ, provided that, of course, this element has an inverse. That is, the GCD of this element and N is equal to 1. So if you remember how the UV couple is computed for Bezout's identity, with the extended Euclid algorithm, then we will use again this algorithm to compute the inverse of an element in Z over NZ.